Okay, today we're going to be talking about adding and subtracting inequalities and solving inequalities by using addition and subtraction. I just said that. Okay, so we've dealt with equations before when they have been equal to each other. Now we're going to see how we deal with inequalities and what exactly our answer means. So let's look at the first one here. X minus 4 is less than 3. Make sure you have those signs down too. You know the difference between less than and greater than. So if this were an equation, we would just add 4 to each side, call it a day. Well, let's see what happens when we add 4 to each side. So plus 4. I have x. 4 plus 3 is 7. X is less than 7. Now, we want to see if adding a number to each side changes anything with our inequality. Okay? So, I don't know. What's a number that's less than 7? 0? Oh, okay. So we know 0 is less than 7. So this is true. 0 is less than 7. Now, if it's true up here, then that means that we didn't violate any math laws by adding 4 to each side. So let's see. 0 minus 4 is negative 4. Is negative 4 less than 3? Yeah! So when we added 4 to each side, nothing changed. So we could think, when we add numbers to each side of our inequality, nothing changed. It's just like an equation. Bam! Okay? So now let's actually graph this guy here. Okay, there's 7 and a beautiful number line. Now we're saying we want the x values that are less than 7. Well, I know some of you in your, days said, well, it's like an alligator, and if the tail, you shade that way. And I just look at you like, what? Okay, let's use some logic. We're looking for the numbers that are less than 7. Well, what numbers are less than 7? 6, 5, 4, 3. The numbers that are that way. So I'm going to do and go get those numbers. Why did we leave that circle open? Great question! In our beginning inequality, we didn't have an equal to sign, so 7's not included. So you have to leave that open. But Mr. Pons, what does this mean? Another great question. Okay, this is the key point of these inequalities. We are saying, before when you had an equation, usually you had one answer. Well, now we're saying that if you take any number that's less than 7, this inequality will be true. Any number at all. So we go from having just one solution to an infinite amount of solutions. Any number that's less than negative 7 makes that true. Okay, now let's try this one. So we have 2 plus y is less than or equal to 14. Well, I got to get rid of this 2, so I'm going to subtract it. Well, when we added, nothing changed. Let's see what happens when we subtract things. So now I have y is less than or equal to 12. Now let's do the same thing we did before. Let's find a number that we know is true here, and then see if that is true up there. Well, what number is less than 12? 0. Yeah, 0. So we know that's true. So this one's true. 0 is less than or equal to 12. Now let's go up here. 2 plus 0 is less than or equal to 14. Well, that's also true. Because 2 plus 0 is 2. 2 is less than 14. So that's good. So we can subtract numbers too, and nothing changed. So our properties of equality, when we added and subtracted, hold for our inequalities too. Great! So now let's graph this guy. 12. Now I have less than or equal to. Since I have the equal to, I could shade in that dot. And now I'm looking for all the y values that are less than 12. Well, I'm not going to go this way, because those are greater than 12. I'm going to go this way. And there you go. Then again, you should be asking yourself, well, what does this mean? Great. We're saying that if you take any y value that's less than 12, so anything over here, this inequality will be true. Okay, let's try one more. Try it by yourself, and then come back to the video. Let's do our favorite letter in the world, X. Actually, we'll do this. 3 is less than or equal to 4 plus X. Welcome back. Okay, let's do what we did before. I got to get X by itself. Now it's on the other side of the inequality. Don't be scared. So what else? Bell still works. So I'm going to subtract 4 on each side. Well, 3 minus 4 is negative 1. And remember, when we subtracted numbers, our inequality was true, so we don't have to worry about the sign. And then we just have X. Now let's graph this out. Here's negative 1. It's a shaded closed circle because of the equal to sign. Now here's where a few people kind of trip up. They see, oh, less than. I'm going to go that way. But remember, we have to read it in terms of X. So we're saying X is greater than or equal to negative 1. We could rewrite this as X is greater than or equal to negative 1. If that's a little bit easier for you to see, then write it like that. Just read it, say, okay, X is greater than or equal to negative 1. X is greater than or equal to negative 1. So we want the numbers that are greater than negative 1, which are going to be all those guys that way. So there you go. And again, remember, our numbers that are over here, that are greater than negative 1, make this inequality true. And since there's the equal to, negative 1 also makes it true. Okay, hopefully this helped.